Hi everyone, this is Ajay again with another video, and in this video we are going to see some device specific APIs of ESP8266, and we are going to use Arduino ID, and you can see we have here our Arduino ID here, and I have certain set of codes here, and these are like specific APIs, which is like if you want to check the details of ESP device, you can get the information of your chip ID, flash ID, and the size of flash, and even the code size. All those things can be read. And what we are going to see here is some of the device specific APIs of ESP8266, and let's look into it. Here you can see we have ADC mode, and this this line, particular line, has to be added before void setup. So it's like it is going to read the VCC voltage, and we are going to I've added one more line here. It is like ESP get chip ID, and I will tell you about this VCC here. We are going to see the next in the next line. Here we have serial dot begin to just push the data on serial console, like whatever we are going to read about ESP are going to be pushed into serial console, and we'll be displaying the data. And we will discuss about WDT disable, which is Watchdog Timer disable. And here we have esp.get VCC, which will be giving the ESP chip voltage. So we can directly read the chip voltage and then display it. And even it will be useful for applications. To say these APIs will be very much useful for developing applications. And here next we have the core version, which is being used right now. So we can read that also. That is esp.get core version is the API function which will be used. And then we have the CPU frequency, that is esp.get CPU frequency in megahertz. That is like I'm giving you you can see here I have some delays introduced. It's like I'm giving some time to read all those data, so it's always good to have a delay here. And then that is flash size, that is to read the flash size. It is like esp.get flash chip real size, which will give you the flash memory size. And this particular thing, that is flash ID, is like esp.get flash chip ID, so it will be giving the ID of flash memory flash chip. Then we'll be displaying all those things. So everything has been pushed into a specific variable, and we are going to display all those things. And here regarding this chip ID, we have some lower 32-bit integer value, and that will be very much close to the MAC address. It's the lowest order bits of the MAC address. So that is the reason I'm printing Wi-Fi MAC address. And you can see how the chip ID and MAC ID match somehow. It's like now when we display it on the serial console, we can see that. And here you can see I have a set of code here in void loop. It is like we have a function that is ESP restart. It's like to restart the CPU. So what I'm going to do is I'm going to give a simple command. It's like through the terminal, serial terminal, I'm going to send just a small r, and then when we just an alphabet R, and once it reads that R, that it will be stored in our RST, this variable. And if we receive R, we are going to restart ESP, so it will restart the CPU. And there is another function called reset. It's like a hard reset, which might be which will definitely affect the register. So it is like it's best to use restart. So it's like SDK restart is like an SDK restart. So what we are going to do is simply until we press the R and terminal, or send R via the serial terminal to ESP device, it is going to just display send R to restart CPU. So this is what we are going to see. And I've already uploaded the code into ESP module. I have connected my ESP8266 Node MCU to the PC, and it is like connected to COM port, that is COM3. And now I'm going to open my serial console. So you can see here it is like send R to restart CPU. And what I'm going to do is, it's like once you upload the code to ESP8266, and when you read a certain when you get this particular message, that is which is being printed specified in the code, that is send R to restart. And if we click on like I'm going to just, you can see I have just typed R here, and then I'm going to send R. And what happens is, it's like it is introducing a restart. It's like a system restart occurs, that is now reset, the system restart has occurred. And now again you can see once it restarts, you can get the VCC voltage, all those things. So maybe I'll just remove the auto scroll, uncheck auto scroll, and you can see it is like VCC is 2974.00. It's like close to 3 volt, and core version is 2.4.2, and then CPU frequency is 80 megahertz, and then flash ID and flash size, that is 4 MB, and then chip ID. You can see I told you the lower bits, that is AF52B4. it's printed in hexadecimal format, and you can see Wi-Fi MAC address which has AF52 and B4. And then after that we get the message send R to restart, which is in void loop. And so again this gets displayed. And the point is, when you upload the code for the first time via serial terminal to Node MCU and then send R, there will be a restart occurring. That is like when a restart occurs, it will also enter into a WDT reset, watchdog reset. So what you do is, don't worry about that. You can just give a manual reset, that is using the reset pin that is available on Node MCU, which is shown here. And then we will discuss about that watchdog timer. That is, I told you that we'll be discussing about this watchdog disable. That is, this is actually a software watchdog disable. And the watchdog reset, which I discussed before, it is like when you first reset, give R command, give like you're going to send R from the terminal to the device, and it will show you a WDT reset, which is the reset cost is due to reset cost number will be 4. That is due to the hardware watchdog timer. But ESP WDT disable or enable is actually a software watchdog timer. And once we disable this watchdog timer, software watchdog timer, what happens is the hardware watchdog timer remains active. So after some few seconds, what happens when you disable this software that is watchdog timer, what happens is the hardware watchdog timer tries to reset the device after a few seconds. So that's what you're going to see. So I'm going to upload 1 minute, just type watchdog timer. So what I'm going to do is upload the code again, and we'll see the output now. Now the code is uploaded. You can see here it is done uploading. I'm going to open the serial console here, and let me just reset my device. And we have send R to restart CPU. You can see after a few seconds the watchdog timer reset occurs here. It's like a WDT reset, because we have disabled the software watchdog timer. So after a few seconds, it's like it is entering. You can see the send R to restart message is actually inside a while loop. So after a few seconds, the watchdog timer, the hardware watchdog timer tries to reset the device again and again. So if we want to enable it, we can use esp.wdt enable and give some the argument as a few seconds. It's like 1000 milliseconds or something like that. So you'll have to just pass the time. So what we are going to do is it's like if you really require Watchdog Timer, software Watchdog Timer, you can use it. So I just wanted to explain how Watchdog the WDT disable works here, and also the hardware reset. Like if we disable this WDT, how hardware Watchdog Timer works. So this is what I wanted to show. So these are some device specific APIs you can use, and there are more APIs, such APIs. So I just wanted to give explanation on few APIs. So we'll meet in another video. Thank you. Thanks a lot. You can practice the code.